Good day, ladies and gentlemen, and welcome to our last video in this series, which deals specifically with scientific notation. Now, scientific notation is, very important, but we don't use it that much in mathematics. But man, I can tell you in physical sciences, or as you guys call it, natural sciences, scientific notation is crucial. So this is Mr. VG, and please stick with me in this video where we're going to dive into this amazing section of work. Scientific notation, ladies and gentlemen, is all about writing long numbers shorter. Now, when I say long numbers, I mean physically there's a lot of numbers. It's not that it's big or small, that it's got a big value or small value, or it's positive or it's negative. No, big numbers. Let's say, for instance, something like 7 million. What if I want to write it shorter? That's where scientific notation comes in. But let me explain to you the logic behind scientific notation. Now, I can write this as 7 times by 1 million. Okay, now I'm going to use 1 million again simply for the reason of that 1 million has a very special use to it. That 1 million I can actually write as 10 times 10 times 10 times 10 times 10 times 10. How many 10s are there? There's actually 1, 2, 3, 4, 5, 6. So I can actually write this as 7 multiplied by 10 to the power of 6. And it's only the tens and hundreds and thousands and millions and billions and trillions where you can actually do this 10 to the power of 6 or 10 to the 4. Interesting. Now, what about 5,000? Now, that's not a very big number, but we want to practice it. So 5,000 I can write as 5 times by 1,000. But 1,000 is 10 times 10 times 10, which is 10 to the power of 3. So I can actually write this as 5 multiplied by 10 to the power of 3. Now that is interesting, definitely. But the question is, that's 6. Doesn't it look familiar? Look at the number of zeros on the left. Oh my goodness, it's the same thing. What about the 5,000? There's 3 zeros there again. The same thing. Coincidence? I think not. Let's look at that. You try and write it yourself in exponent or in scientific notation form. Oh my hat. 4 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's your answer. But what if I've got 3,200 now? You try and write it in scientific notation. Now, some of you might just go and look at the zeros and go, this is 32 times 10 to the power of 2. There's nothing wrong with it, but it's not scientific notation. Okay? It's not scientific notation. But then what is scientific notation? The thing is, ladies and gentlemen, there's actually 2 numbers in your answer in front of the comma. There's a 3 and a 2, which is not scientifically acceptable. It must be 3,2 times 10 to the power of now. How many decimals were there? There's a 0, 0, and a 2. So that's why there's a 3 there. Okay? Oh my hat. Must it always be that way? Actually, yes. Because this is 3,2 times by 1,000, which again is 10 to the power of 3. Now what if I've got 702,000? How would that look in actual scientific notation? Now that you know, scientific notation may only have one significant value in front of the comma. Significant meaning non-zero. 7,02 times 10 to the power of 1, 2, 3, 4, 5. And there's your answer. As simple and as easy as that. But what if I've got a really small number? Like 0,0003. Now, if you think back at converting from decimals to fractions, I can say this is 3 over 100,000. Now, 100,000 is 10 to the power of 5, because that is again 10 times 10 times 10 times 10 times 10 times 10. And by doing some Hong Kong magic, it's actually 3 times 10 to the negative 5, because it is divided by. Now, please, I get that you have never done this, and some of you are going to look at this and go, what? So how on earth did you get that? Just stick with me and I'll share with you how I got that. But let's try and find a short way of doing this without the magic. First of all, the comma needs to move how many times? 5 times. So I'm going to say 3 times 10 to the power of 5. But because we are working with a small number, that's why I put the negative there. So in your mind, you must remember, small numbers work with negatives. Now, how we get from the 3 over 10 to the 5 to 3 times 10 to the negative 5 is actually applying the second law in a very funky way. Actually, we teach it to you in grade 9. So please do not worry about this at all, ladies and gentlemen. You must remember, when I'm working with small numbers, my exponent by my 10 is just going to be negative. So, 3,12 multiplied by 10 to the power of, is it a large number or a small number? It's a small number. So therefore, there's going to be a negative in my exponent. How many times do I move that comma? 4 times. So 3,12 times 10 to the negative 4. Now you go and try these two sums yourself. Write them for me in scientific notation. If I look at the first one, it's going to be 1,2 times 10 to the power of something. Is it a small number or a large number? It's a small number, so therefore it's going to be a negative. I move the comma 7 times, so it's times 10 to the power of negative 7. You've got this, guys. You've got it. Let's try the last one. 4,104, and I move the comma 9 times. But is it a small number or a big number? It is a large number. So I'm going to say 10 to the power of positive 9. And there you've got it, ladies and gentlemen. You've got it. This is Mr. VG signing out. Have a beautiful day and good luck with the exams and the tests coming up. I know you can do it. Keep on practicing. Have an amazing day. Cheers.